Okay, now let's see. What is the variation of pressure with the depth? The question is, if I go deeper in the fluid, what will be the pressure? For that, let's draw this diagram. Suppose that we have Z, the vertical axis, and then X. We take a piece of fluid in a space with the side, vertical side, delta Z, and then horizontal side, delta X. With that piece of fluid, we have the weight. The weight is the volume times rho g. If we have delta X in this side, delta Z in this side, and then delta Y in the Y direction. So the volume is delta X, delta Y, delta Z. This one. It times rho times G, it becomes the weight. Directed downward, negative. And then we have the pressure at this level is P1. Imagine this is a box. This is delta Y. This is delta X. So the area here is delta X times delta Y. The resultant force is F1. F1 is P1 times delta X times delta Y, which is this one. Directed upward, positive. On the upper side, P2 here, F2. F2 is P2 times delta X, delta Y. Directed downward, negative, so this one. This piece of fluid is in equilibrium. It means the sum of force in the Z direction is 0. We have F1 directed upward, this one, minus F2 directed downward, minus W directed downward, equal to 0. We cancel delta X. We cancel delta Y. By then you have P1 minus P2, P1 minus P2, minus rho G delta Z equal to 0. Or I will write here, sorry, P2 minus P1 equal to negative rho G delta Z. Delta Z is Z2 minus Z1. I can write Z2 minus Z1. P2 minus P1 equal to negative rho G Z2 minus Z1. If I ask what is P1 minus P2, it is negative rho G Z1 minus Z2. P2 minus P1 equal to negative rho G Z2 minus Z1. What is the pressure at the surface here? At the surface of the liquid. If P2 equal to P1, let's put this is 0.1, this is 0.2. So P2, P1, it's the same point, Z2 minus Z1, 0. So P2 equal to P1. Now let's say 0.2 is this one. P2 minus P1 equal to negative rho G Z2 minus Z1. Z2 minus Z1 is negative. P1 is atmospheric. P2 minus PATM, P0, equal to negative rho G Z2 minus Z1. So P0 is atmospheric, PATM. It means this one is P gauge. If this one is H, P2 minus P1 is positive, rho GH. By applying that formula, P2 minus P1 equal to negative rho G Z2 minus Z1. That is to say that everywhere when the distance from the surface is the same, the pressure will be the same. So it means at a depth h, the pressure will be the same with this one because this is also at the depth h. The same here, the same there, the same. As long as the depth is the same, pressure at point A, the same with B, C, D, E, F, G. That is atmospheric pressure plus rho g h. The depth is h. But the fluid must be interconnected. Pascal law. A pressure change in a confined fluid is transmitted throughout the fluid by the same amount. If you have a pressure here, for example, a certain value, that same value will be transferred here as long as the level is the same. And then the fluid is connected. You see, because we have seen previously, as long as the level is the same, when it is connected, the value of the pressure is the same. Same with this. If the fluid is connected, if the level of fluid is the same, the pressure will be the same. Pressure the same, but force depending on the area. So the force here is P1 times the area. The smaller area, it means the force is small. But you convert to a big column here, where the area is big, A2, the same amount of pressure times the big area, you are going to produce big value of force. So that is how the car jack works, hydraulic car jack. With a small force, you can lift the car.